All right, so we're doing significant digits rules for multiplication and division. Yeah, yeah. You can do your notes any way you want to. Okay, I would recommend that you do your notes in pencil, because if you make mistakes, in fact, there are occasionally things I even want you to erase. So we said the significant digit rounding rules for addition were the same as those for subtraction. The same is true here now for multiplication and division. They're the same rules. Okay? So what's true for rounding and multiplication is true also for division. And the way that we're going to do in this class almost exclusively, all the multiplication division we do is all one sort of singular problem. We're just multiplying fractions together, okay? And a process we call dimensional analysis. Okay, you'll hear me use that term a good bit, dimensional analysis. Oop. Analysis, S on the end. Dimensional analysis. Okay? So I want to kind of review just a little bit of some math concepts. All right? There are some math concepts that will help you in this class, and because we do a good bit of math in here. And there are some math concepts I just want you to forget about. Okay, the process you've been taught in math, cross multiply and cross divide, I want you to pretend that you never learned that in here. Okay, because if you try to do that with a lot of the math we do in here, you're going to get really messed up. All right, so forget cross multiply and divide. But I do want you to remember some basic math concepts that you have learned before, and it involves things like this. If I have two things that are equal to each other, and I put them in a fraction, what is that fraction going to be equal to? 1. All right? And so that's the basic idea behind all of our conversion units. Okay? This is the basic concept behind conversion units. And we do a lot of conversion units. Okay? And here's another basic algebra concept. And how many of you are taking algebra now? Okay, how many of you already had algebra 1? Okay, has anybody had algebra 2 already? Okay, good, good. All right. That's good for you because you're supposed to either have taken algebra 2 or in it right now to take this class. But for most of it, you probably do just fine anyway, okay? All right, so if I have a math problem like, or an algebra problem that's like this, can anybody tell me how to resolve that problem into a simpler form? Speak up. Cross out the x's, okay? And that's just y, isn't it? Okay? All right, what about if I do this? What do I do now? Did you say cross multiply? It's all right. It's all right. That's okay. It's kind of hard to get past something you got used to doing, isn't it? You know, when you try to train your brain to think that way. Okay. Well, just tell me what I should write over here for the answer. Xy over x, which comes out to be the same thing as before, doesn't it? Because the x's cancel. All right. Well, suppose I just simplify that, since I know that's the way it's going to work out. If I have an x on the top here and an x on the bottom here, I can just go ahead and cancel those out. Does it make sense? And I just get Y. Does that make sense? All right. This is the basic concept behind dimensional analysis. In dimensional analysis, units of measurement and species in chemistry would include any kind of chemical. It could also include electrons or neutrons. Okay, species are treated like X's and Y's. Okay? Works the same way. Okay. Species, that's like a chemical symbol, like H2O. Okay? H2O, if I had H2O on the top and H2O on the bottom, that's like an X on the top and an X on the bottom, you can cancel them out. Alright? Okay, so let me give you a problem. Let's work through that, and I'll show you how we're going to apply all these things, okay? Well, I'll tell you what, before I even do that, let me give you something else to know about that's kind of new. How do you write cubic centimeters? A superscript 3, right? So centimeters cubed, okay? That's a cubic centimeter, all right? And what that means is we're taking, we're measuring a volume. Volume is something that has height and width and depth, okay? And so what we have to do is multiply 3 length measurements to get a volume, all right? Well, anybody in here planning on a career in medicine of any kind, or veterinary science or anything like that, okay? Then you'll probably see this symbol a lot. A cc is a cubic centimeter, which is a cm superscript 3, okay? And as it turns out, a unit we use an awful lot in chemistry is also exactly the same volume, and that's a milliliter. Okay? Now, you need to commit that to memory, okay? That's just something you have to memorize. All right? So, let's see. Here's a problem. And so this is the chemical symbol or the elemental symbol for lead. So to help you with interpreting the kind of problems you're going to face a lot in here, I'm going to tell you that when I say a number per some other number, okay, the long and short of all that for this class means that this many grams of this species is equal to a cubic centimeter of this species. Okay? that can be thought of as meaning they're equal. Just that word right there. Okay? I could also write this as 11.3437 grams of lead, or I could say it like this. There are 11.3437 grams of lead in a cubic centimeter of lead. That would also mean 11.3437 grams equals a cubic centimeter of lead. Does that make sense? So the word per or the phrase are in, okay, those are clues that the two things are equal. Does that make sense? Okay, that'll help you a lot in interpreting problems, all right, for this class. Now, you'll see some other things too, but hopefully those two will get you kind of started, and you'll pick up the others as we go along when it might come up, all right?